Let's do this problem right here. The question is asking, if a string is tied to a slender bar at A and the bar is allowed to hang freely, what will be the angle between AB and the vertical? So they are saying they attach a string right here and just let it freely hang, right? So when it hang freely, what's going to happen is the vertical is going to be, so if you imagine this object is rotating, so when we hang freely, this is going to go down, then the vertical is going to be exactly along the centroid. So they are asking what is the angle between AB and the vertical. So we have to find the angle that makes between the centroid line and the AB. So to do that, I have to first calculate the centroid, and then I have to draw a line along that. Then I can calculate the angle. So first of all, let's see how we can calculate the centroid. In this case, this is not the area. There's no surface inside of this object. This is just line. So we have a line that's going all the way right here. So we can't do the area equation for this one. So there's a different equation to calculate length. So in this case, what we have to do is the equation is we have to find x bar and y bar to locate the centroid. So in this case, x bar is going to be sigma xi li over sigma li. Then to find the y bar, the equation is sigma yi li divided by sigma li. So this is the equation to find the x bar and y bar. So in this case, so I have to know these values, sigma xi li, sigma li, and sigma yi li. Let's see how we can calculate this one. So first of all, I take this figures separately. So I can take this line separate, and the arcs separately and calculate all the values. So first of all, I will create a list of tables. So this is going to be my figures, and length, and then we have to calculate the xi, yi, then xi li, and yi li. So let's put the units for these things. So the unit for length is going to be the inch. So it's going to be inch. Li is also inch. Yi also inch. Inch times inch square, and this is going to be inch square 2. So let's put all the values, so all the figures. So I'm taking the bottom part first, so this line. So if I take this one, so I'm taking until this point right here. So if I take this is 8 meter. So the length is 8 meter right here. Xi is going to be exactly middle of this line, so it's going to be 4 meter. And since this line has no heights, therefore it's 0. And if I multiply 8 and 4, it's going to be 32. And if I multiply y and length, there's no y's, therefore this is going to be 0. Then if I take the next figure, I'm taking this line AB. So AB. So to calculate AB, the distance is not given, but we can calculate using Pythagorean theorem. So according to, this is a hypotenuse, right? 90-degree triangle hypotenuse. So we can use the Pythagorean theorem. So according to Pythagorean theorem, we know the radius of this arc, that's 4 inch. Therefore, the diameter is going to be 8 inch. So 8 square plus 8 square square root. So that's going to give us the length of this one. So 8 square plus 8 square root. If I do that, I will get 11.314. And xi is going to be, so this is the point we are calculating all the centroid. So in this case, x bar is going to be exactly middle of this one. So we have to calculate the middle of this one from x-axis. So from here to here. So it's going to be exactly 4 because the total distance is 8. If you see, the B is ending at exactly same point as this. So it's going to be 4 inch. 4 inch. And then y is going to be, the height is also, we know that the arc of the diameter of the arc is 8 inch. Therefore the height of this one also same thing. Therefore the middle radius is going to be the same as the middle part, that's 4 inch. Then if I multiply xi times li, that's going to give us the value of 45.256. Also yi li also same thing because we are multiplying same numbers. Therefore 45256. Then let's move to the arc. So length of the arc is calculated by using phi r. So if I use phi r, radius is we know the radius, that is 4 and 5. So the 4 phi is my length of the arc, because 2 phi r is for full circle, but since this is a half circle, we use phi r. Then xi is gonna be so we have to locate the centroid of this one. Centroid of for line, since this is not a area. For area, we know that centroid is going to be exactly in the 4r by 3 phi, but in this case this is a line. For this one, it's a different equation. It's 2r over 5 phi. So this is the equation to locate the centroid for the line arc and line half circle, right? This is a half circle, so this is the equation for half circle line. So that's why it comes here. So 2r means 2 times 4 divided by 5, 2 times 4 divided by 5, but that's for the centroid from here to here, but we know there's a 8 inch before that, so we have to add that one too. So if I add that one, 8 plus 4 times 2 times 4 divided by 5, that's going to give us, let's see what happens. So 2 times 4 divided by 5, that will give us 10.546. Then y is going to be exactly in the middle, so we know the diameter is 8, so it's going to be 4, and then if I multiply xi and li, that's going to give us 132.52, and if I multiply yi and li, that's going to give us 50.264. Now we go to all the values. Now we need these three informations: xi, sigma xi li, sigma li, sigma yi li. So we had to know the summation of length, that's sigma li. So summation of length comes out to be, if you add all them together, it's going to be 31.88, and summation of xi li is going to give us sigma 209.776. Then sigma yi li gonna give us 95.58. So from this one we can now substitute in this equation. So if I substitute xi li, I will get 209. So we know this is 209.776, so we can substitute here 209.776 divided by the li, so it's 31.88, and that's gonna give us the value of 6.58 inch. This is inch square and this is inch, so if you divide each other you will get 6.58 inch. This is our x bar. Now we have to calculate the y bar. So y bar is going to be yi li divided by li. So yi li is 95.58 divided by 31.88, and that will give us the value of 2.996 inch. 996 inch. Now we have x bar and y bar. Now we can locate the centroid in this object. So if you look at this object, so x bar is going to be 6.58, so it means it's somewhere along here. Let's say this is 6, so it's going to be somewhere along here, and y bar is going to be 2.996. it means radius is 4, therefore 2.9 mean maybe like almost here, right? So if I locate this centroid, it's going to be exactly right here. So we can draw a line along this. The question is not centroid, right? The question is not asking centroid. The question is asking if a string is tied to the cylinder bar at A. So they are tying a string right here, and bar allowed to hang freely. What will be the angle between A and the vertical? So when you allow this to hang freely, what's going to happen is this will rotate, this object will rotate down, and this will be the exact vertical. This will be the vertical, like this will be straight line, and the others will be moving other side. So that's how the object will be when you rotate, when you hang it freely, it will rotate, and this will be the exact vertical point. So the question is asking what will be the angle between AB and the vertical. So they are asking the angle that between this AB and this vertical. So this is the angle that we have to find. So let's see how we can do this. First of all, we know this is a right angle triangle. We have two right angle triangles. So in this case, first this is a right angle triangle right here. Also, we have a right angle triangle, big right angle triangle right here. So that is making what is this? So let's call this one theta. This is theta. This is, let's call this one alpha, and let's call the one we have to find beta. So if I So we can calculate the theta by using these two sides. We know this radius is 4 inches, therefore the diameter is going to be 8 inch. And also we know the distance of this triangle is 8 inch, so 8, 8. So if I use the tan theta, so tan inverse means opposite over adjacent. So in this case, theta is equal to tan inverse opposite over adjacent. Opposite is 8, adjacent is 8. Therefore 8 over 8, that will give us 45 degree. So that is theta. Now I have to calculate alpha. I can calculate alpha because that's also a right angle triangle, and we know the distance because we calculated the x bar and the y bar. That's going to be the distance for the opposite and the adjacent, right? So now we can apply that one here. So therefore alpha is going to be equal tan inverse, opposite is going to be the y bar. So y bar is 2.996 2.996 divided by the adjacent, that's x bar, that's 6.58. And if you find the value, you will get 24.48 degree. So since this theta is 45 degree, alpha is 24.48 degree, it means the beta is going to be theta minus alpha. That will give the beta. So we can simply subtract the value. So it's going to be theta minus alpha is equal to 45. That's equal to beta, which is equal to 45 minus 24.48 degree. And if you subtract both of them, you will get 20.52 degree. So beta is equal to 20.52 degree. So this is the final answer for this question. So they are asking what will be the angle between AB and the vertical. This is going to be the angle when the object rotate, and this will be the centroid will be the vertical. Therefore the angle that makes with the vertical is 20.52 degree. So that's how it's done. I hope you guys like this video. See you next time.